Nick Schrock, founder of Elementl, the company behind the popular orchestration platform Dagster. Welcome to the Data Exchange podcast.
Thanks for having me, Ben.
So Nick, I start out this podcast when I have open source leaders by quoting their text back to them. So here's what I can glean from the Dagster website. Dagster is an orchestration platform for the development, production, and observation of data assets. And it is the data orchestration platform built for productivity. It is one of the foundational tools for the modern data platform. So my first question is, it seems like this, so orchestration is a very kind of exciting area of data engineering. I don't know why, but so much activity, so many companies. But it seems like each project kind of selects what they accentuate. So some accentuate ML orchestration. Some accentuate microservices orchestration. So why did you folks decide to accentuate data orchestration in particular?
Yeah, because, the reason why we started the project was not to build an orchestrator. It was to solve a problem. And the problem that we saw is that in the modern context, effectively every company and organization has a data platform, meaning a set of tools and services that to manage all the data assets in an organization that drives nearly all decision-making, both data-informed decision-making by human beings, as well as automated decision-making by machine learning systems. And, looking at the data, kind of the lineage of the project, right, is that bulk of my career was at Facebook. I was an engineer there in 2009, 2017. I actually worked on a team that served our application developers. So started this team called Product Infrastructure. That team ended up creating React, which is kind of like the most popular JS framework. And then I personally created the initial version and was the first tech lead of GraphQL. So that was like the space where I operated. And then I left and I started to figure out what to do next. And this data infrastructure just kept on coming up over and over again as like the biggest and most important technical liabilities for companies of all stripes, both inside and outside the Valley. So I came in at the lens of like, oh my God, there's this huge problem. And effectively the infrastructure and the software, which drives these data platforms, which are essential to our society. Like these systems are determining who gets a loan and not, right? Like very core, who gets how we price medical care. So we came at it through that lens. And what I discovered is that orchestration to me was clearly this incredible leverage point where you could tell that people were drowning in complexity. And, effectively the structure of these systems, whether it's an ETL pipeline or an ML training pipeline, they are creating graphs of computation that produce and consume data assets. And it's the orchestrator that is kind of at the heart of that. And I saw the existing orchestrators defining the problem too narrowly in a way where they viewed themselves as we are ordering and scheduling computations in production. To me, the orchestrator is instead the center of gravity, where you should actually define all your data assets and the pipelines that produce them. And that should be a metadata-rich kind of arena, and that it should have a fast local development lifecycle, be built for engineers, et cetera, et cetera. And to me, it was clear that the orchestrator would be the central linchpin for a control plane for a data platform to make it so it's comprehensible and observable, and the place where you can kind of integrate and bring everything together and stitch everything together to be coherent. Because right now, the world is so chaotic. And
by the way,
data engineers.
You're a good founder because you did your homework in that you started out by talking to people, finding out their pain points. So with that said, so obviously when you start a project like Dagster, you can't solve everything. So
that's right.
Were there certain personas and use cases that you had in the back of your mind for Dagster?
So the persona and use case that we really had in mind was a software engineer or a data engineer who like considers themselves a software engineer. So someone who cares about having CI/CD pipelines and testing and a fast development life cycle, and they want to be able to they don't just want to stitch scripts together. They want to build like fully formed platform and assets, and have a proper engineering process around it. Right. One of the trends that I saw, some people call it data ops, which is a loaded term, but effectively the software engineeringification of the data domain. It was like a massive trend, wanted to target, and effectively build an orchestrator for them. Funny enough, actually, initially the project
this is something actually I've had conversations. So I'm an advisor to Databricks. I've had conversations with the founders of Databricks about this notion of, bringing software engineering rigor to data engineering. This whole because there's not even a kind of a well-known way to do unit or software testing for pipelines, right? So
that's right. So that's one of the big problems we're trying to solve, right? Is what's interesting about data engineering is that I think who explains this the best, I don't know if you've ever interviewed him, Chris Berg, who's the founder of Data Kitchen and kind of the originator and one of the proponents of the data ops movement. And he describes data engineering as actually a syncretic mix, a combination of both software engineering and manufacturing. So meaning that, you can think of a data pipeline as effectively as a factory where you're ingesting raw materials, the raw data, and then instead of an assembly line, there's an assembly DAG. And it shares a lot of properties with a factory. So like, for example, you can't control the inputs, right? Like what I consider normal programming, like a web app, you have a form. And if someone mistypes something, like the box can go red and you say, hey, user, you have to re-enter the data. Whereas in the data pipelining system, you have no control over the ingest typically. And that means like you actually need QA at every step along the way. You need to think in terms of statistics and not strict correctness often. So it's a different mental framework, which I think is really interesting.
It's also kind of complicated because usually at scale, it involves multiple distributed systems. And
that's
so
right.
How do you do formal testing? What if there's side effects, right? So that you have to keep track.
That's right. So this was one of the first things we worked on, and meaning that our goal was to move as much testing as possible as forward up into the developer lifecycle as possible. So you should be able to get at a minimum, right? Ensure that your DAG is fully formed before you push it to production. Ensure that you don't have any configuration errors before you push it to production. Be able to test as much business logic as possible prior to pushing it to production. Be able to load up the graphical tool locally on your machine to visualize what work you're doing on without having to spin up a bunch of infrastructure. And you have to encode very specific constraints into the system in order to enable to do that. Being able to have a lightweight Python API for invoking your pipelines. And that's like very contrasted with we'll probably get to it, but Airflow is the kind of biggest open source player in the space, and
not as big as people think.
Not as big as people think. We're working on it. But yeah, Airflow was built with like very different constraints and assumptions in mind. For example, in order to kick off a DAG in Airflow, you have to run a heavyweight scheduler process locally. There's actually no way to just write a Python API call to invoke a task or a DAG easily, right? And that lack of basic capability is just incredibly taxing on someone who wants to have a fast development lifecycle. So, we really kind of from day one, this whole notion that these systems are clearly complex enough that we need to bring more software engineering process in order to effectively manage the complexity. That is if you just go to any big, even medium-sized kind of data platform company, it's clear that the chaos has spun out of control.
Yeah. By the way,
it's just like it's like the biggest dumpster. It's the biggest developer experience dumpster fire I've ever seen in my career, and I've seen some real doozies.
By the way, there's two keywords that you've used, both starting with O. The first one is ops, the other one is orchestration. And as you were talking, it just dawned on me. So for me, ops always has three parts, right? So there's monitoring, automation, incident response. Orchestration, you have a scheduler, you have an executor, you have some sort of metadata store, and monitoring. So it seems like
right.
an orchestration solution is central to ops, right?
Yes, absolutely.
Right. You can't have
an orchestrator.
You can't have a rigorous ops practice without it, right?
That's right, and that's one of the first things a lot of our users and customers tell us is that for the first time we have a single pane of glass for an operational pane of glass for our entire data platform, right? Where we can both like see information about what's happening and be able to resolve and act upon that information to restart jobs
and then if you wear your ops hat, things will go wrong with probability 1. So the question is, how can I alleviate the mistake as quickly as possible, right? So
that's right. Yeah, you are designing for failure,
right?
Meaning, like, because of the nature of the problem, it goes back to what I was saying about how it's a mix of software engineering and manufacturing. Where like manufacturing, 100% there will be errors in a manufacturing process. So you have to have QA at every single intermediate point, and you have to design the system to handle failure. And the measure is how quickly you can recover from failure, as opposed to trying to goal on making the failure rate 0 or something at every intermediate step. So a big part of orchestration is correctly surfacing errors and making it clear how to act upon them in order to resolve them. And we really think the orchestrator is the natural kind of center of gravity for that activity.
So I have my two next questions. The first one is very much of a softball complementary question. And then the follow-up question is a contradictory challenge question. So the first
All right, I'm ready for it.
So the first one is, I really love what you guys, the Sandy Reese's post on software-defined assets. So tell our listeners at a high level what you folks are trying to achieve there, and how far along are you in terms of implementing it?
Yeah, that's a great question. So, simply put, we think that software-defined assets is a very ambitious product direction and a product iteration. And what it is that we think that we think of the world in terms of data assets, right? A data warehouse table is a data asset. A file in a data lake is a data asset. A machine learning model that has been trained, that lives somewhere, a pickled file somewhere, is a data asset. That is what the business of what we're trying to do here.
Feature store, right?
Yes, feature store, also a data asset. Like anything where like computation is producing data then consumed downstream by someone else. And what we feel right now, the current approaches are effectively use a task-based orchestrator in order to produce these data assets, right? We think instead that the orchestration needs a defining abstraction called the software-defined asset that effectively is a piece of software that declares an asset that you intend to exist, meaning that the primary identity for a particular asset should be a software definition rather than a particular materialization of that asset in time. Like it's the software thing that actually matters. Because if you really think about it, right? Like for example, if you like dropped a table from a data warehouse, the asset still exists because you can recompute it, right? You can like reinstigate a computation and rematerialize and it's back. And that means the primary identity of the thing really should be the asset itself. So that's like very abstract. and more concretely,
Yeah. So
in terms of,
yeah. So Nick,
go ahead.
go into how does that affect an engineer? How does that affect how they write code?
Right. So one is that it's a far more declarative approach. So in a task-based orchestrator, you write a task and it happens to produce an asset somewhere, and then you have to manually insert it into a DAG or a flow or a job, depending on the abstraction of the system that you're working in. So you have to write a task, and you think about that function. Then you have to embed that in the centralized DAG artifact that's shared a bunch of people. And then as a result, the orchestrator knows nothing about that the asset that gets produced in the end. So you're ended up having to do a bunch of manual work in order to integrate it with a bunch of different systems. And for example, if the only information you have and you're trying to debug something is like the name of the asset, when you go into the orchestrator, the ops tool, right, you just have to have the secret knowledge that, oh, I know that this pipeline has some random name, produces this asset, lives over here. There's nothing that connects everything. So the asset-based approach, you no longer have to manage a centralized DAG. That's a critical function. You simply declare your asset, declare your upstream dependencies, and then the system kind of constructs that centralized DAG on your behalf, which is both extremely convenient. It means there's because like if you're an Airflow user, for example, or any other user,
so you would still need to tell the system the order of the sequence of events, right?
Correct. But the reason why is that, there's you can think of dependencies in two ways. One is like a time-based execution dependency, and the other is like a data dependency, where it's like literally and by declaring things in asset space, you're saying that I depend on this upstream asset, right? So the dependency ends up being the execution dependency. And effectively, you can think of it, the execution dependencies are downstream of the data dependencies.
Oh, so the system, the system you're building will somehow just construct the DAG, the necessary.
Exactly.
DAG. So then, and so you also use the word declarative. So to us data people, the classic declarative thing is SQL.
That's right.
Right. So where you just kind of declare what you want to happen, and then there's some magic optimizer that makes it happen. And by the way, this reminds me, I don't know if you remember, but in the early days of Spark, I mean, before Spark SQL, you had to like kind of figure out what sequence of functional operator should I do to get to this other format of the data. And then
That's
after
right.
you do that, you keep questioning in your head, is that the most optimal sequence of transformations? And so once they had this Spark SQL thing, wow, this is great because the optimizer takes care of all of that, right? I don't have to worry about it, right? So
right. So this is a declarative technology at a different layer in the stack than SQL. So SQL is a declarative technology for expressing kind of business logic computations, right? We're declarative at kind of the next layer of the stack, which is how all those different assets end up interrelating to each other, regardless of whether the asset is defined in SQL, DBT, Spark, Pandas, whatever. But a lot of the same rules end up applying in terms of once you have your dependencies expressed in this asset space, you can, for example, get far more clever in terms of how you do your orchestration, because the system can manage more of it for you. In the same way that once you use Spark SQL, it's the system that's in effect writing the code that
most optimal.
You would have done with data frame or
the most
before.
optimal code is written for you, right?
Yeah, that's right. So I think that's like very concretely expressed in our system as kind of the different way the system can take over, where you can go to our UI, look up the name of the asset, right? Not a task, the asset. And then there's literally a rematerialize button. And you can just say like, rematerialize this asset. The system goes and figures out what it needs to do in order to do that. And we're just at the start of exploiting like what that means, right? So we have like a basic memoization system, so you don't unnecessarily do recomputations, but we're very excited about the directions we can go in terms of managing more of the orchestration, be smarter on the orchestration on the user's behalf once they have this declarative notion in place.
So what is the transition from classic Dagster to this new software-defined asset Dagster?
That's a great question. So, this is not like a complete rewrite of the system by any stretch of the imagination.
No, I mean from a transition for the developer. Is there going to be a big difference in the way? Do they have to rewrite everything?
They do not have to rewrite everything. So, in the end, right, you kind of the most basic way you can think about it is that both an op, which is kind of our notion of task, and an asset, they both are just Python functions. Okay. But effectively convert an op to an asset, you have to decide once you define like that Python function, you have to define right next to it what its upstream dependencies are, as opposed to separately doing it in a separate DAG. And underneath the hood, right, one of our software defined assets actually contains an instance of an op. So it's just a layer built on top. We're still working on all the different like migration strategies that would be necessary if you have like a large installed Dagster installation, but we don't anticipate it being particularly difficult because it's actually, because what it actually is, we're just like almost like imposing more constraints on the existing computations they have rather than like forcing like a radically new API. And most of the differences end up being expressed in how it's rendered in tooling and whatnot.
So Nick, does this model allow me to mix and match between different, I guess, even programming languages, right? So you can imagine in the AI space, someone is doing something in C++ over here, and then maybe passing over to something in Python, and I don't know, So do these assets have to be all Python?
No. And that's actually one of the huge values of them. So one of the things we witnessed is we saw this emerging concept of the software-defined assets, but expressed in different language and different systems. So if you go up to like Airbyte or Fivetran, right, you configure sources, right, which are effectively tables, right? Tables that might not exist yet, right? In DBT, which is very popular technology, right? Every DBT model is effectively a software-defined asset there, where you have this thing, you write a SQL statement, it has these ref commands within it, which determine its upstream dependencies, similar in reverse ETL tools and other tools that are out there. So, one of the huge value propositions here is the ability to have deep integrations with those tools and effectively suck out their metadata and their asset graphs into one unified fabric. So if you look at a traditional orchestrator, and let's say you have a very simple pipeline that's like, I do an ingest job, I invoke DBT, and then I do reverse ETL or something. In a traditional task-based orchestration system, that's 3 tasks, right? So there's very little meta information and knowledge of the system that's encoded in the orchestrator. And really you don't have that much of an idea of what's going on in the system. In the software-defined asset way, what we're doing is we're kind of reaching into those systems and pulling out the metadata and then constructing a cross-technology lineage graph, which then we orchestrate. And that's extremely powerful. So you kind of, instead of having to completely integrate a totally external orchestration tool, lineage or observability tool, and having to do like really a lot of work to integrate it, ensure that's up to date and whatnot, you just build that into the orchestrator and you naturally get it as a result of the APIs that we have. And then you can mix and match those technologies with, say, arbitrary Python, doing machine learning or whatever, which is a really common use case.
So what is the status of this today, and where would you be at the end of this year?
So statuses today is that we've launched it. We're onboarding early partners. I would call it a late stage beta we've been working on software-defined assets since the summer.
So just to clarify, is this Elementl or is this Dagster?
Dagster.
Dagster.
So this is all Dagster. We're pushing out a release in June that will kind of change it so that we are asset first in our system. Like new users will use the asset tutorial. We're going to really double down on that. And then our goal is to cut a 1.0 release in the second half of the year in terms of that. So, we are onboarding early users who are using kind of beta software until June. Then we're going to cut it over and kind of release it for prime time. But we are extraordinarily excited about this direction.
So do you think that so obviously you guys have thought this through carefully and you're doing this to make things simpler, but do you think at some level that developers and engineers will find it a bit challenging in that they have to change the way they think?
Stuart Butterfield of Slack has a great line where he says, if you're not changing behavior, you're not really innovating. So I think with any innovation, you have to have it compelling enough so that people are willing and even excited to change their behavior and mental framing.
So your docs, you should have some killer examples in the docs to really convert people into this mode of working, right?
Yes.
Yeah.
And we
like that first couple of examples in the docs should really be something that, this is the way to do it, right? So
yeah.
No,
I think for the people who work in the modern data stack, the kind of immediate sort of dopamine hit here is we can show with just a few lines of code, we stitch together their existing tools into a unified lineage graph that is executable rather than just like a post hoc observation of what happened. And just like that aha moment is incredibly powerful. And just the other thing I like to say about the software-defined assets piece is that we really think it also makes Python a first-class citizen in the modern data stack, in the modern data ecosystem. We're in a very SQL maximalist moment right now, where there's a lot of momentum towards SQL. Well, we've been waiting for SQL to eat all compute for a few decades now. I don't think it's ever going to happen. We need arbitrary code in data platform systems. Not all computations can be expressed in SQL. And really, what's been interesting in this modern data stack world that's dominated by execution of the cloud data warehouse, ingest tools, reverse ETL tools, is that Python's really been left behind.
I think some people will say you can express almost everything in SQL, but that doesn't mean you should, right? Because basically, when you have access to a modern programming language, you have functions, methods, classes, things that make your code much more easy to maintain for one thing, right? So.
Yeah, and and for different personas, right? There's different. Some people really like that. Some people think that actually the declarative nature of SQL makes it so that those don't have enough value. You
can really write some convoluted SQL code, man. It will work, but no one can read it. My challenge question to you, which is not really a challenge, it's more of a joke, really. So the name of the project is Dagster, but I noticed that you and many of the other orchestration projects, they recognize the importance of DAGs, but you're now at the point where you're trying to kind of hide DAGs from developers in some ways, right?
Well, we're trying to hide the execution DAG. Yeah. The DAG of tasks becomes implementation detail, but above that, we still have a DAG. It's a directed acyclic graph of assets. Right. So it's, this is actually a great discussion topic, because I think all the orchestration systems are going in kind of divergent directions, actually, which is very interesting.
Right.
So you mentioned that you had Prefect on the podcast, and they have a really interesting new product direction called Orion. They're kind of like 2.0 release, which is, they're a move beyond DAGs.
Or their thing is your code is the best expression of your pipeline or your workflow. So
right. So you just write code and it turns into a workflow. It actually makes it, as a technical artifact, a direct competitor or in the same approach as temporal, which is currently used mostly for microservices orchestration, but they have the exact same belief where it's just like you just write normal code and then effectively it turns into a workflow by using these special APIs.
The flight guys also kind of mentioned to me that they kind of are trying to do this for ML work orchestration in particular.
Oh, that's interesting. I haven't followed that particular product direction of theirs. But if that's even more interesting, because effectively what that moves you to is that those systems are more general, they're more imperative, they are operationally more complex, because you're effectively implementing a distributed state machine, and you can have infinite loops, and it's a less constrained model actually. We're going in the total opposite direction, which is we are specifically targeting the data platform use case. And we think for that, the right approach is still a more declarative approach. So this ecosystem is actually separating, which I think is going to be a great outcome for all stakeholders, actually, because I think that people will get like the type of experiences they want. And I think like it's actually going to be quite healthy for the ecosystem.
So while I have you here, let me pick your brain on a few data trends in general. So the first one is fragmentation and consolidation. So you brought up the modern data stack, right? So modern data stack is really, I have access to best of breed point solutions, and now I can kind of piece them together into this kind of beautiful architecture diagram. And every time someone writes a post like that, you'll see comments on social media, this is great, but this looks complex. So how much longer do we tolerate kind of all of these kind of point solutions and having engineers piece them together, which is great for the resume of the engineer, but maybe not so great for the company that will have to maintain these things, right? So what's your sense? Am I barking up the wrong tree here?
No, I think it's like one of the most important problems that exists. I don't know if you followed this particular data conversation on Twitter, but there was an article that came out that was called Unbundling Airflow, and it's about how the Airflow is becoming unbundled into all these different point solutions.
Is there enough to unbundle?
What's that?
Is there enough to unbundle?
Well, that's it. You should go read the article and see if there's but I kind of 2 days later, it was actually interesting because we had been thinking along these same lines, and we were about to launch software-defined assets. And we really think of software-defined assets as a way to consolidate these point solutions into one like organizing fabric that makes it comprehensible to operate and understand. So I kind of wrote this response called Rebundling the Data Platform, which announced our product direction. So I think bundling or consolidation must occur. The current state of the universe is far too chaotic, fractured, difficult to operationalize. It's a nightmare for purchasers. There's too many vendors there. It's too much right now.
Look at the ML ops space, right? So you got a experiment management tool, then you got some kind of model governance, model serving, monitoring. It's just
that's right.
No one is gonna. So, no one will want to deploy these things like that, right? So,
right. So to me, the question is, if there's going to be integration or bundling, it's around what axis will it occur? And there's kind of two options here. There's vertical and there's horizontal. So what I mean by vertical is that you work with Databricks, right? It is natural and logical for them to develop versions of each of these kind of categories. Like they have a job scheduler, they're going to build data observability features, they're going to build lineage features, and on and on and on. So that's vertical integration, where you bet on a single vendor and you kind of get like a data platform in a box, right? Snowflake's going that direction, and I assume other companies will as well. That's possibly the world we're going to end up in. I don't think it is. I don't think people want to purchase or use software like that, or at least the lion's share of people don't. I don't think that people want to go back to the world where you just like had Oracle control your entire stack. It limits innovation. They have a ton of leverage over you pricing wise.
Let me push back a little bit. So the main difference is there's still a bit of open source, even though it's vertically integrated, right? So
right. It is
open file formats. Underlying projects are not in, so obviously Databricks has Photon, but there's still Spark and so on and so forth. Yeah. Anyway.
Totally. It's not as proprietary and not as vertically siloed as something like Oracle. So like, it's not the same thing, but kind of spiritually, right? It's like in that direction. The other kind of consolidation or integration access are these like horizontal integration layers that allow multiple tools, both above and below, to plug into some tool or standard that makes the world more comprehensible. And that's our bet. And that's the way we think this world should be consolidated and simplified. And we think the orchestration layer is the natural pillar of a control plane that kind of allows all these different technologies to interplay and intermix and be comprehensible, right? Our vision is the orchestrator is like the data platform control plane, where this is where you go, and it's a system of record of all the integrations you have with systems that produce data assets, the definitions of those that should exist, a asset catalog that records when those things were materialized, and then how all those assets interrelate, all in a single tool. But in a way that's pluggable, where you can use any computational substrate, any storage substrate, and also be able to plug into the higher level tools, right? We don't imagine taking over like all lineage data cataloging, all data quality, et cetera, et cetera. We are kind of more those concepts. We are data quality, data lineage, data observation aware, in that we have this base level capability, which you can plug into via APIs, and that more specialized tools and where they focus on that vertical can kind of be bootstrapped, right? So you don't have to do all your integrations, start all your integrations from zero all the time. So, I think it was I stole this analogy from Ben Stansel, who's one of the Mode co-founders, but he's like, he said that, the data ecosystem needs sort of like an iOS, where there's like a unified substrate that can organize your world and provide some constraints and rules and tell how things interrelate. But within that superstructure, there's still an incredible amount of heterogeneity and innovation. Exactly where that layer is going to exist and how it's going to exist is a super interesting question, and will like be one of the dominant questions to answer in data infrastructure in the next decade.
It'll be the lake house, man.
The lake house?
No, just kidding. So the other trend that you are very familiar with, probably because you worked so long at Facebook, is so a lot of times when we talk about data infrastructure, particularly with the tools you brought up, it's mainly around structured data, right? So, but the reality is that in the ML world, now you're looking at progress in, granted, right now it's a bit siloed, right? So you have progress in computer vision, you have progress in language models, progress in speech, and so on and so forth. But people are now starting to imagine a world where you have multimodal models that blend different kinds of data. So how is our data infrastructure positioned for a world where we have multimodal data? I mean, because a lot of the things that people are excited about, like DBT, that's all structured, right? So
that's right.
Orchestration seems like it's should be able to handle different modalities, right? So
absolutely right. We are completely neutral to both computation framework, like what your actual compute does it in, whether it's Python, Spark, or some other system, and we are neutral to how it's stored and in what format. Because there is life outside of SQL in the data warehouse and lots of interesting work in data processing across all sorts of applications, including the ones that you named.
Yeah, computer vision.
But all
Computer vision people are struggling because they don't have the, the tools that we take for granted on the structured side, right? So,
right.
Yeah.
Yeah, and I think a lot of the borders between these different disciplines as well, because the underlying nature of the problem are actually quite porous and should be, meaning that a lot of a person who's working in ML's job is ETL, right? They have to process data and get into the formats that's right for their training algorithms or whatever. So a lot of the core work that they do is actually the same work that a data engineer would do. So there's a ton of value in having an orchestration platform, for example, that can span both of those personas. And we see that, kind of our two major personas and entry points are one, ML engineers adopt us a lot, as well as what I'll call like a modern data engineer. So data engineers who kind of conceptualize themselves as wanting to use software formalisms, and then also are using best of breed tools. And they actually intersect as well. So you have like a data platform person who then wants to support an ML team as well. And they want to do that with a unified data platform. And Dagster is a natural home for that. So we see this in the heterogeneity of the use cases that we see. We have a bunch of users who are in bioinformatics, for example. We have users who are in energy, who actually have to deal with tons of unstructured data because they're gathering data from sensors and oil wells and whatnot. We certainly see this we see that what you're noting, the heterogeneity in our user and customer base.
So yeah. So the final trend I want to pick your brain on is democratization, right? So which has so basically, when I look at the people who work with data, you have data engineers. There's fewer data engineers than data scientists, of course, but then analysts dwarf both of these, right? So, and now we're starting to see kind of data integration tools that target analysts, right? So the low-code, no-code data integration tools. So I don't imagine that you guys care who's using you at the end, right? So analysts can be using an orchestration tool. There just has to be a layer, a UI for them to use it somehow, right? So do you think about analysts at all?
We absolutely do. But the way we think about it is that our initial prospects and adopters are engineers. Like the first people who touch our system are engineers for sure. But what's increasingly common is that data engineers, and sometimes they retitle themselves as data platform engineers, their job in life is to serve other stakeholders who use other tools that need to be integrated into the orchestration layer. So classic example here is dbt, right? Where dbt owns this analytics engineer persona. Typically when we're dealing with and we're integrating with dbt, which is super frequent, we're very complementary technologies, you have a platform engineer who is empowering the analytics engineers. And then so the analytics engineers doing work in dbt, and then they're orchestrated in the broader context of the data platform in Dagster layer. I'm really excited about the low code, no code stuff insofar as, I don't think we can go back to a world like Informatica where you have a completely siloed low code, no code tool that is completely absent from a software engineering process. Look, properly conceived, where you can imagine kind of a platform engineer interfacing with those analysts to figure out the right way to incorporate those low code, no code solutions into the broader engineering process that drives the data platform. That to me is super interesting.
And by the way, Nick, the key is, as you probably know from Facebook, the key here is that analysts probably know the data much better than anyone else, right?
Totally.
Yeah.
Totally. But I think the lesson people need to learn from the success of dbt is that they didn't succeed by making it so that the analysts are totally self-serve. They don't have to learn anything. They're isolated from the engineering process, et cetera. dbt succeeded because it brought the analysts into the engineering process, but in a way that kind of aligned with the grooves of their mind. So it was intuitive and whatnot. And I think democratization in the data platform space needs to look like that, where you provide this empowerment tool, but the user has to, learn new behaviors in order to work with it so that they're kind of productive in the broader context of the entire platform. And so those are the low code, I haven't really seen it yet, but those are the low code, no code solutions that would get me excited about that. And you see I'm an investor in a company called Glean, which kind of wants to bring BI into the software engineering process. You can imagine like companies like Hex going in this direction where, you can build like notebooks, which are in fact complicated apps, which you could check into source control and then work on over time. So I think we're getting there. In terms of democratizing people to contribute back to the data platform, it's about building tools that fit the minds of those personas, but then incorporate them into a software engineering process in as light of weight way as possible.
Great. And with that, thank you, Nick. This has been a great discussion. You are a great articulate founder. One of the best explainers I've come across. So thank you, Nick.
Great. Thanks for having me. Appreciate the kind words.